Good evening, Ron.
Good evening, sir.
So, can you please introduce yourself?
Yes, sir. So my name is Rohan Gupta, and I belong to Uttarakhand, and I have completed chemical engineering in 2022 September, and currently I am preparing for Barc interview.
Okay. So, Rohan, what are the subjects that you have prepared?
Sir, my subjects are heat transfer, CRE, FM. And I have not prepared thermo.
Okay. And mass transfer?
No, sir. Masses.
Okay. So, Ron, can you write a very simple reaction A gives B on the board?
Pardon, sir?
Can you write a reaction A gives B on the board? Okay.
Is it visible?
It's not visible. That's why I have said that you must have been using iron webcam. Okay, no worries.
Just a second.
Have you used that?
Sir, it will take few minutes. If you allow me, then I can use that also. I have uploaded it on my laptop.
चलो कोई बात नहीं, अभी स्टार्ट करते हैं हम लोग, ठीक है?
So we'll take it into the next interview, okay?
Okay.
Yes, next session पे आप कर लीजिए.
Now, you define the rate of reaction for that particular reaction that you have written on the board.
Rate of reaction for can be defined for A as the rate at which A disappears to form B is a rate of reaction for A.
Yeah. So can you now write it down mathematically? Since you are not able to see what you are writing, you may just speak aloud while you write.
The rate of reaction of disappearance of the rate of reaction of A is equals to rate constant into concentration of A disappearing to the power n, where n is the order of the reaction.
So I think is it always the case what you have written, that it is what if the reaction is 2A gives B?
If 2A gives B, then it would be depending whether the reaction is elementary or non-elementary.
That's an elementary reaction.
So then n would be 2.
So again, my question is, can you define the rate of reaction?
Rate of reaction rate of reaction should be the rate at which A disappears, and it is dependent on the if it is any elementary reaction, it depends upon the stoichiometry of the reaction.
Yeah, so essentially rate of reaction is the rate at which the reactant is consumed or the rate at which the product is produced, and then you have to write the differential term in the number of change of reactant or the product.
Minus dCA by dt.
Yeah.
Now how to find that rate expression, whatever the reaction you have wrote? So can you find the rate expression for that?
Sir, while taking n equals to 2 or general n?
No, while taking n equals to 2. Take the n equals to 2.
Yes.
Please speak up, Rohan.
Yes, sir. Sir, I would be quitting minus dCA by dt equals to kCA square, and then taking CA square in the downward direction. dCA by CA square equals to minus k dt, and then integrating it.
Now in that same question, if I would ask you what are the methods to find rate expressions? Can you tell me that?
Question. I might be using integral method or differential method for that purpose.
Yes.
Okay. So can you tell me about the integral method? Or you can start with differential method then.
Integral method is basically an iterative method where we assume rate kinetics equals k Ca to the power n, and then by taking n equals to 1, we put it on a graph and we try to have a straight line. And with that experiment runs at t1 we have Ca1, t2 was Ca2. Then two graphs, sir, अगर वो दो ग्राफ मैच करते हैं, that means what we have assumed that is correct.
But we don't know the value of k.
चलो आप ग्राफ पे आ ही रहे, तो मैं आपसे कॉन्सेंट्रेशन वर्सेस टाइम का ग्राफ इसका बना के दिखाइए आप. ड्रॉ कॉन्सेंट्रेशन वर्सेस टाइम.
This particular
yes
second order one.
Yes, just draw it.
That is visible.
Now draw the same graph when the components A and B, when they are non-equimolar in mixture. Draw the same graph.
Yes.
वो कर्व आपने स्ट्रेट लाइन कर्व लिया है, राइट? और एक कुछ
सर मैंने y में ln का पार्ट रखा है, ln m-1 m 1 minus x, whereas on x axis I have taken time. That's why it is a straight line.
Okay.
So what is the slope of this straight line?
Sir, the slope is kCA0 m-1.
Huh?
kCA0 m-1.
Okay. So now, can you tell me about different types of reactors?
Sir, yes. Sir, there are two types of reactors: flow reactors and non-flow reactors. Flow reactors include plug flow reactor and mixed flow reactor, whereas non-flow reactors include batch reactor, semi-batch reactor.
So what is the difference between PFR and a CSTR?
And I need to write on board or just to explain?
You explain. You can just explain.
Sir, in plug flow reactor, there is no axial mixing, whereas in CSTR uniform mixing takes place. PFR can assume to be a summation of CSTRs, and
yeah, so in PFR, the reactants are flowing from one end to other end. There is no back mixing.
yes, no back mixing takes place in PFR.
Yes. And the reactants react as they flow along the length of the reactor.
Yes.
And what is CSTR?
Sir, as soon as the reactant enters CSTR, uniform mixing takes place. The concentration of the reactants come down at a rapid rate. System का sir concentration तुरंत एकदम down हो जाता.
Okay. So now I want to perform a reaction of first order.
Yes, sir.
In PFR and CSTR. Okay. In which case I will require less volume, given that I need to have same percentage of conversion. So you drew a line that was going down quadratically. So what was that line?
This line. Sir, this line basically shows a relation between the inverse of rate of reaction and the conversion.
Is it in that nature?
It is a graph between -1 upon RA versus conversion.
Okay, you go on.
And the volume required by the PFR would be less as compared to CSTR. If the order of the reaction is greater than 0.
Why?
You can understand this by the area of this graph. Basically tells us about the volume.
Can you physically explain what is the difference that is occurring because of which I am requiring low volume?
Sir, as the reactants enter into CSTR, the concentration drops rapidly, so as rate of reaction also decreases.
But rapid drop हो रहा है तो rapid conversion भी हो रहा है.
ओके सो नो प्रॉब्लम. चलो रोहन, मैं आपको एक इंडस्ट्रियल बैच रिएक्टर मुझे डिजाइन करना है. ओके तो क्या आप मुझे बता सकते हैं कि हाउ डू यू, आप कैसे इस इंडस्ट्रियल रिएक्टर को बनाएंगे, बैच रिएक्टर बेसिकली. कैन यू टेल दैट? डू यू हैव एनी आइडिया
हाउ टू स्केल अप?
यस. What are the factors basically that will be requiring while designing that industrial batch reactor? That is important. That I'm asking.
Scale up.
अरे आप बताइएगा ना कि सर से पूछिएगा कि आप कन्वर्जन, सर क्या कन्वर्जन रहेगा, कितना वॉल्यूम रहेगा, ये सब चीजें आप पूछिएगा ना पहले.
I'm not getting exactly what.
Okay, then we'll continue with the CSTR PFR thing only. So what you said is right, that PFR requires less volume whereas CSTR requires more volume. What is the advantage of having a CSTR over PFR? If that is the case, why don't we always go for a PFR? And we still are using CSTRs?
Case for order greater than 0.
Huh?
That this is basically the case an order is greater than 0.
So most of the reactions are of a non-zero order, right? Zeroth order reactions are very few in nature.
Sir, I cannot recall. Right.
Okay. So what other factors than conversion and volume will, other than the volume, we need to consider for considering a reactor choice?
Volume, we have input what we are taking, contacting pattern.
No, you are going way too ahead. So first point you need to consider is the conditions that you need to maintain. So is it easy to maintain in a PFR or a CSTR? What if you are running a highly exothermic reaction in a plug flow reactor?
Yes, sir.
So theoretically, PFRs do have a higher conversion than CSTR, but CSTRs have better control over maintaining the conditions than PFR. Extremely high exothermic or endothermic reactions are essentially carried out in a CSTR than in PFR. So now, if I want to do a particular reaction in CSTR, I need to have a bigger volume vessel. Now I came up with the idea, what if I start making a combination of CSTR and PFR for doing the same? So can you, on the same graph which you had drawn earlier, FA by minus RA versus
Conversion.
concentration or the mole fraction. So on the same graph, can you show me how I can split that particular system into multiple reactors? Such that the volume will be very small.
Such that volume would be?
Such that I can reduce the volume requirements.
For order greater than 0, first we would like to place PFR, then small CSTR, then the larger CSTR to have the maximum conversion.
First would like to place a PFR, then CSTR,
smaller one, and then larger CSTR. That's the maximum conversion.
Okay. Now I just want to play with CSTRs. Okay, I don't have a choice of making a PFR. I just want to have multiple CSTRs. So what will happen if I just start adding number of CSTRs? Will the volume decrease, volume requirement?
As compared to PFR? Or if it just
single CSTR? You can use the same graph.
if we use multiple CSTRs, then the volume required as compared to the single CSTR would be lesser.
Okay. Now what happens if I start increasing the number of CSTRs? Will the volume requirement come down?
we increase the number of CSTRs, as compared to single CSTR, always the volume required would be high. Would be lower, sorry.
Would be lower. And can it match to the volume of PF?
Your voice.
जब आप अनलिमिटेड CSTR, अनलिमिटेड स्मॉल CSTR लगाओगे तो इट विल बी इक्वल टू PFR, right?
Yes.
The volume of small CSTR and basically n reactors and CSTR will be equals to 1 PFR. That only sir is asking. आप इतने हाइपरटेंशन में क्यों? सिंपल लीजिए, चिल लीजिए, ओके? तो चलो मैं नेक्स्ट सब्जेक्ट पे मूव करता हूँ, ओके? सो गाइस, सो रोहन, आप मुझे आप बताइए सबसे पहले इंडस्ट्री में हीट ट्रांसफर कहाँ पे आकर होता है?
Exchangers.
हीट ट्रांसफर कहाँ पे होता है इंडस्ट्री में? Would you tell that?
Heat exchangers.
So what is a heat exchanger?
The heat exchanger is a device to basically to lower the temperature of a hot fluid or to increase the temperature of a cold fluid.
So do you know how
can't I
many?
use it to change phase?
Yeah, yes, sir. It can act as a condenser as well and boiler as well.
So what is a heat exchanger?
The heat exchanger is a device basically to exchange heat, and that heat can lead to a change in phase or temperature as well.
Good.
Draw shell and tube exchanger. Draw.
So, schematic diagram.
Yes. Define the inlet and outlet, okay? And draw 1-2 shell and type heat exchanger.
And this is basically, if visible, this is tube side inlet, and this is tube side outlet, whereas this is shell side inlet and shell side outlet. And these are tubes, and this is the shell, and these are baffles.
How many tubes you have drawn?
Basically,
How many?
2 I have drawn.
2. Okay. So I have said that draw 1-2 shell and tube exchanger. Can you tell what is 1 and 2 in that?
1 is the number is the shells, and 2 is the tubes.
Okay. You have drawn something like its type of baffles, right?
Pardon, sir. Can you repeat?
You have drawn something like baffles. Am I right?
Yes, sir. Yes, sir.
So what is its use?
So baffles are basically used to enhance the heat transfer at the shell side and to support tubes.
What is the size of baffle? What baffle size cutting do we use?
This baffle size. Yes, baffles are cut. Percentage cut takes place.
Yes.
And that is basically to increase the velocity on shell side, but we need to take care of the pressure drop as well. That is, I'm not getting exactly the name, sir. Baffle cut, if I'm not wrong. Baffle cut
Yes.
is.
Baffle cut is about 75%, right? तो 75% आपका baffle cut होना चाहिए. No issues. जो baffles होते हैं वो support के लिए भी होते हैं. जो tubes होते हैं tubes को support provide करते हैं. तो चलिए इसी point पे आते हैं. अगर मैं आपका tube का spacing करूं तो tube के spacing में आप मुझे बताइए tube का spacing कैसे होना चाहिए? वेदर इट शुड बी रेक्टेंगुलर, ट्रायंगुलर, सर्कुलर, कैसा होना चाहिए ट्यूब का स्पेसिंग?
Sir, tube spacing is basically known as comes with the concept of pitch.
Yes.
What we need to define as a pitch. If we take the triangular pitch, then it is good for high pressure drop. If we take square pitch, then it is good for viscous fluid.
Great.
Okay. Yeah.
So add on, Nachiket sir.
His time is almost completed, so we'll go to the third interview. It's 10:45. We'll go for the next interview.
तो रोहन मैं आपको बताऊंगा, सर भी आपको बताएंगे नेक्स्ट सेशन में जब आपका होगा. ओके, सो वी आर एंडिंग.
We will either
आपका जो भी बेसिकली रहेगा अभी इसके बाद का फीडबैक,
I will give you one.
yes. आपको फीडबैक बताया जाएगा बाद में. ओके
ओके सर.
हाँ, सो आप मीटिंग में रह सकते हैं रोहन. ओके
ओके,
सुन सकते हैं.
थैंक यू.
ओके.